Welcome to This Explainer. I am absolutely thrilled to have you here today. If you've spent any time at all in modern software development, you already know that building applications is all about microservices. But let's be real for a second. Managing the logistics of how all those tiny independent services actually talk to each other, it can be an incredibly complex nightmare. So today, we're going to demystify all that complexity by looking at a tool that is a literal game changer for modern architecture, Apache Kafka. To really wrap our heads around the sheer scale of what we're talking about today, I want you to think about just one word: trillions. Apache Kafka isn't just some basic communication tool. It's a massive, distributed powerhouse that is literally capable of handling trillions of events every single day. Trillions. That staggering, mind-bending scale is exactly why some of the biggest tech companies on the planet rely on it to keep their systems running smoothly.
Okay, let's dive into this. Here is our roadmap for today's journey. We'll start with the microservices challenge, then enter Apache Kafka, cover why you should choose Kafka, break down its core components, and finally, go over implementation best practices.
Starting off with Section 1, the Microservices Challenge, or as I like to call it, the absolute headache of interconnected systems.
So here is the million-dollar question. How do independent services actually communicate without creating total chaos? Think about it. You break an application down into a dozen microservices so they can operate independently, right? But they still need to share data to function. If you build direct point-to-point connections where service A talks to service B and service B talks to service C, you very quickly create this massive, fragile web of dependencies. And if one single piece fails, that failure cascades and crashes the entire system. That right there is the core problem we are solving today. Which brings us nicely to Section 2, enter Apache Kafka, the ultimate intermediary layer. So what is Apache Kafka? Well, it's an open source, highly reliable, and fault-tolerant distributed event streaming platform. Fun fact, it was originally developed by LinkedIn way back in 2011, mostly because their traditional message queues were just totally buckling under their massive networking scale. Its primary job is to publish, subscribe to, store, and process streams of records in real time. Simply put, it takes that brittle, messy web of direct communication and replaces it with a highly organized, highly efficient central nervous system. Let's move to Section 3, why choose Kafka? Let's break down its four main superpowers. Superpower number 1 is decoupled architecture. Now, what's really interesting about this concept is the shift it creates. In a tightly coupled system, services depend directly on each other, which means one little update can easily break something else. Kafka completely shifts this paradigm by acting as an asynchronous intermediary layer. Your services don't even need to know about each other anymore. They literally just talk to Kafka. This isolation ensures that your services can evolve, update, or even completely fail independently without crashing your whole system. And honestly, that flexibility is a massive win. The second superpower is real-time data processing. Kafka absolutely thrives in environments where speed is everything. Whether you're building live monitoring systems, running instant recommendation engines, or trying to detect fraudulent transactions in mere milliseconds, Kafka's high-throughput capability processes that data as it happens, without skipping a beat. All right, moving to our third superpower, scalability and fault tolerance. Look, microservices are designed to grow, which means your infrastructure has to be able to grow right along with them. Kafka's distributed nature guarantees horizontal scalability. As your data volumes inevitably go up, you simply and seamlessly add new nodes and partitions. And what happens if a server just goes down? Kafka doesn't panic. Its distributed design makes it incredibly resilient to node failures, so your data stays safe and your systems stay online. And the final superpower is centralized data management. Having a centralized data hub significantly simplifies your life across dozens or even hundreds of independent services. Instead of data just floating around in isolated pockets all over your network, which, let's be honest, is a lot like trying to find a specific homework assignment in a messy teenager's bedroom, Kafka acts as your single source of truth. This centralized approach cuts down on data redundancy and ensures system-wide consistency and integrity. Okay, let's slow things down just a bit and shift gears to Section 4, Kafka's core components. It's time to look under the hood. At the very foundational level, we have topics. These are simply the categories where Kafka stores its streams of records. Think of them as dedicated sorting bins within our central logistics hub. So user signup data streams into a signups topic, while system faults stream directly into an errors topic.
It's basically the core way Kafka organizes this massive, continuous flow of information.
Interacting with those topics are your producers and consumers. It's a very straightforward decoupling. Producers are the applications that write and publish data to the topics. They're sending the information in. On the flip side, consumers are the downstream applications that subscribe to those topics so they can read the data out.
Now, to hold all this together physically, we rely on brokers and clusters. And this setup brilliantly illustrates the infrastructure. A broker is just a single server running Kafka. But, Kafka rarely works alone. Multiple brokers group together to form what we call a cluster, and they share that massive storage and processing load to make sure the system is continuously available and lightning fast.
Finally, we have partitions. Topics are actually subdivided into these partitions, and they essentially act as parallel processing lanes. So why does this matter? Well, dividing a topic means that multiple consumers can actually read from it at the exact same time. This is absolutely crucial because it drastically increases your system's overall throughput and unlocks true horizontal scale.
Let's zoom back out for our final stop, Section 5, Implementation Best Practices. Consider this your blueprint for success.
So the crucial point is that implementing Kafka successfully requires some real discipline. Step 1. You absolutely must define clear data contracts and schemas. If your producers and consumers agree on the format of the data being exchanged, you completely eliminate downstream compatibility issues. Step 2. Actively monitor and manage your cluster health so you can catch bottlenecks before they ever impact your users. And Step 3. Please don't reinvent the wheel. Leverage existing tools like Kafka Connect to easily integrate with external databases and use Kafka Streams for the heavy-duty real-time data processing.
As we wrap up this explainer, I want to leave you with one kind of mic drop question. Is your architecture actually ready for real time? We've seen how direct microservices can so easily turn into a chaotic, fragile web of cascading dependencies. But we've also seen how Apache Kafka cuts right through that noise, serving as this incredibly scalable, decoupled, and highly reliable central nervous system. So take a really hard look at your own interconnected systems today. Are they resilient? Are they fast? Or are they just a bottleneck waiting to happen? Your blueprint for real-time efficiency is right here. Thank you so much for joining me today, and go build faster systems.